James Webb will go where no other telescope has gone before.
The James Webb Space Telescope has been revealing surprising discoveries that challenge our current understanding of the universe. From unexpectedly large and bright galaxies to black holes that don't behave as expected, these observations are forcing scientists to rethink long-standing theories. As researchers continue to analyze the data, they anticipate even more groundbreaking insights, potentially reshaping our understanding of cosmic evolution and the fundamental laws governing the universe. Webb Telescope hints at cyclic universe. For over 2 years now, the James Webb Space Telescope has been digging into the universe's deepest secrets, and what it's finding is blowing minds. It's spotting structures out there that, according to everything we know, simply shouldn't exist. Our current models can't explain them, and that's where an interesting theory comes into play. One championed by none other than British physicist and Nobel laureate Roger Penrose. Penrose has a bold idea. The Big Bang wasn't the start of everything. Instead, it was more like a giant cosmic reset button, a transition from one universe to another. In his view, the universe operates in a continuous cycle of destruction and rebirth. Think of it like a phoenix, but on a universal scale. And here's the kicker. The latest discoveries seem to back him up. One of Penrose's intriguing predictions involves something called Hawking points. These are mysterious remnants from a universe that existed before ours. Named after Stephen Hawking, these points might hold evidence of this before time. If Penrose is right, these Hawking points are essentially fossils from a previous cosmos, lingering in our own like cosmic breadcrumbs. Now, let's talk about infinity. While many scientists believe the universe is infinite, our perspective is painfully limited. From Earth, we can only see a small bubble of what's out there, a region known as the observable universe. This is basically the area where light and other signals have had time to reach us since the beginning of the universe, roughly 13.8 billion years ago. Beyond that, it's a giant question mark. So, why does this matter? Well, the observable universe is like looking through a keyhole into a vast mansion. We see some rooms and hallways, but the majority is out of view. And yet, even within this tiny fraction, we're finding these baffling structures and patterns that hint at something much bigger. If Penrose's theory holds, it could mean the universe isn't a one-time event, but part of an eternal cycle, an endless loop of death and rebirth. When we think about the Big Bang happening 13.8 billion years ago, it's easy to assume the farthest we could possibly see would be 13.8 billion light-years away. But nope, it's not that simple. That's because space itself has been expanding non-stop since the beginning of time. So the distances we're talking about aren't static. They've been stretched out over billions of years. When you factor that in, the edge of what we can observe, called the event horizon, is actually about 46.3 billion light-years away. Every single point in the universe has its own observable universe. That means if there's some alien civilization chilling billions of light-years away, they're seeing a slice of space that we'll never be able to observe. And the same goes for us. They'd never be able to see everything we can. It's like we're all watching the universe's movie from different seats in a massive theater, but no one gets the whole view. Because of this cosmic perspective problem, we can only guess at what exists beyond the edges of our observable universe. Scientists call this region the unobservable universe, and it's where things get super speculative. A lot of researchers think the stuff out there probably looks similar to what we see locally: galaxies, stars, maybe some black holes, just more of it. But we really have no way of knowing for sure. The universe is full of surprises, like these black holes that are really flipping the script. Mind-bending, black holes defy cosmic rules. The universe is full of weirdness, and scientists think the parts of space we can't see might be even stranger than we can imagine. But honestly, the stuff we can see is already blowing our minds. Take the black hole the James Webb Space Telescope recently found. It's been given the scientific name Li 568, and it's a gravity monster, unlike anything we expected. This black hole formed just 1.5 billion years after the Big Bang. That's pretty early in cosmic terms. But what's really crazy is how it behaves. It's gobbling up matter 40 times faster than our theories say it should be able to. Basically, it's like the universe didn't get the memo on how black holes are supposed to work. Lie 568 fits into a bigger, baffling pattern scientists are noticing. There are a bunch of black holes out there that are way too massive for how early in the universe's timeline they appeared. For example, there's this quasar, a super bright galactic nucleus, with the catchy name J120+0641. It dates back to the cosmic twilight era, a time when the universe was just starting to light up with stars and galaxies. But despite being from that early period, this quasar already weighs over 1 billion times the mass of our Sun. Yeah, it's insane. These discoveries are forcing scientists to rethink how black holes form and grow. According to what we thought we knew, it shouldn't be possible for these objects to get this big, this fast. And yet, there they are, just casually breaking the rules. Scientists hope the James Webb Space Telescope could help explain how these massive early black holes came to be. But even a closer look with its super advanced mid-infrared instrument didn't reveal any special feeding mechanism that could explain their rapid growth. So here we are, scratching our heads, wondering how a supermassive black hole could be fully formed when the universe was only 5% of its current age. Our current models just can't make sense of these cosmic premature babies. That means it's time to think outside the box. When the usual explanations fail, researchers have to come up with new ideas, sometimes ones so bold they could flip our understanding of the universe upside down. One exciting theory comes from astrophysicist Sophie Kidman of the University of Cambridge. When asked if these giant black holes might have formed from structures that existed before the Big Bang, her response was refreshingly open-ended. The exciting thing about this question is that nothing is ruled out. It's a big deal because we're talking about potentially rewriting cosmic history here. Some researchers think these black holes in the early universe might have formed through a process called direct collapse. Basically, instead of forming from the slow accumulation of gas and stars over time, these black holes could have skipped all that and gone straight from massive, early structures into fully fledged giants. If that's true, it opens up a world of possibilities. Could there have been pre-Big Bang structures that gave these black holes a head start? Or are we missing some fundamental aspect of how black holes grow in extreme conditions? And if you think black holes are messing with our understanding of the universe, wait until you hear about these galaxies. Universe-breaking galaxies rewrite cosmic history. Some scientists believe the observations we're making now might actually hint at something huge, like proof that there was something before the Big Bang. Publications suggest that if black holes grow efficiently enough, they could theoretically form from very light seeds and still have time to bulk up into the monsters we see today. Astrophysicist Sophie Kudmani has pointed out that while this is just one possible explanation, it introduces a groundbreaking idea that the universe might be part of a cycle. Instead of the Big Bang being the absolute beginning, it could have been just the latest in a series of cosmic resets, where the end of one universe leads to the birth of another. This idea, called the cyclic model, has gained traction as we push the limits of what modern cosmology can explain. Take the recent discoveries made with the James Webb Space Telescope. They've sparked what some are calling an astronomical crisis. One major bombshell came in early 2023 when scientists identified 6 massive galaxies from about 13 million years after the Big Bang. That's way earlier than they should have existed, given our understanding of how galaxies form and evolve. These galaxies are as massive as our Milky Way, despite existing at a time when the universe was supposedly too young to support structures that large. This completely contradicts what we thought we knew about the density of matter in the early cosmos. Naturally, these mysterious galaxies earned the nickname universe breakers because they're basically shattering our models of how the universe works. So, what's the deal? Could these discoveries mean our theories about the Big Bang, galaxy formation, and the early universe are incomplete, or even wrong? If the cyclic model holds any weight, It might mean the universe has gone through endless cycles of death and rebirth, with remnants of previous universes influencing what we see today. Galaxies in the early universe seem to have been overachievers when it came to making stars. A research team from the University of Geneva recently studied 3 of these star-making powerhouses, nicknamed the Red Monsters, because of how they appear in James Webb Space Telescope images. What they found is blowing our minds and our theories out of the water. Normally, galaxies form pretty gradually within halos of dark matter. These halos act like invisible nets, pulling in gas and molecules with their gravity. Over time, these trapped materials come together and form stars. In most cases, only about 20% of the captured gas gets turned into stars. But these red monsters, they're converting an insane 50% of their gas into stars. That's more than double the usual rate, and it's happening just 1 billion years after the Big Bang. So, how are they doing it? That's the million-dollar question. Right now, nobody really knows. These galaxies seem to be defying everything we thought we understood about how galaxies grow and evolve. For context, galaxies aren't supposed to be this productive so early in the universe's history. Our current models can't explain how the red monsters managed to pull off such rapid star formation. It's as if they had some sort of cosmic cheat code, and scientists are scrambling to figure out what it might be. What we do know is that something extraordinary must have happened in the earliest stages of the universe, something that gave these galaxies a serious head start. Whether it was unique conditions, an unknown mechanism, or just some cosmic fluke, it's clear the rules of galaxy formation in the early universe were far more flexible than we thought. And if you think the universe has a clear starting point, Penrose has a theory that totally flips that idea. Penrose's cyclical universe. What if the Big Bang wasn't really the start of everything, but just the middle of a much bigger, ongoing story? That's the core of an intriguing theory from Roger Penrose, a British mathematician and physicist who won a Nobel Prize in 2020 for his work on black holes. Penrose doesn't see the Big Bang as the absolute beginning of the universe. Instead, he believes the universe operates in cycles, constantly being reborn after each end. According to Penrose, the Big Bang is more of a transition between 2 cosmic eons, like a reset button that kicks off a new chapter in a never-ending loop. This is part of a larger cyclical model of the universe, where every time one era ends, it paves the way for a new one to begin. In his view, the universe continues to expand until everything breaks down into light and energy. As it approaches its final stages, all matter would disintegrate, and what we know as time and space would lose meaning. Penrose believes that in this extreme environment, where nothing has any reference to time or space anymore, a new Big Bang is inevitable. This process would happen repeatedly, creating endless cycles of cosmic destruction and rebirth. One of the coolest parts of his theory is about black holes. According to Penrose, as the universe reaches its end and all matter gets swallowed up by black holes, those black holes will eventually evaporate entirely. But instead of disappearing, they'll leave behind a special kind of remnant, something that can be found in the next universe, acting as a sort of imprint or trace of the previous cosmos. These remnants would be like cosmic fossils, carrying memories of the universe that came before. Roger Penrose's theory doesn't stop at just imagining a cyclical universe. He claims to have found actual evidence of this idea in the cosmic microwave background radiation. For those not familiar, the CMB is like a snapshot from the early universe, created about 380,000 years after the Big Bang. It's basically the leftover radiation from that time, still floating around and filling the entire cosmos today. What Penrose has identified in the CMB are mysterious circular patterns, which he refers to as Hawking points. These circular spots can be seen in data from both the Planck and WMAP satellites, and they've caught the attention of the scientific community because they could be clues from a previous universe. The theory goes that these points are remnants, or echoes, from a prior cosmic cycle, a sign that the universe has gone through this process of rebirth before. To really appreciate why these Hawking points are so significant, we need to understand a bit about the cyclic model of the universe. One of the core ideas here is that cosmological inflation might have actually started before the Big Bang, in an earlier cosmic eon. The traditional view is that the Big Bang kicked off everything, including the rapid expansion. But Penrose's model suggests that what we call inflation could be the result of the universe of a previous eon, which underwent its own inflationary growth before collapsing and starting a new cycle. In simpler terms, Penrose is proposing that the rapid expansion we usually associate with the beginning of our universe might not be a one-time event. Instead, it could be part of an ongoing cycle that repeats with each new universe. And these Hawking points, these circular patterns in the CMB, are potentially evidence of that. They're the ghosts of a previous cosmos, leaving traces in the fabric of our current universe. With all the new discoveries and the weird cosmic inconsistencies found by the James Webb Telescope, it begs the question, is our universe really the universe, or just one cycle in an ongoing cosmic loop? This is actually a big topic in the world of astronomy right now, and it's far from settled. If Penrose's cyclical universe idea holds true, the universe as we know it could just be one chapter in an eternal cycle of destruction and rebirth. That would mean the Big Bang wasn't the start of everything, but rather a transition from one eon to the next. Each time the universe ends, it just sets the stage for the next one to begin, with everything repeating in an endless loop. And if all this isn't enough to make you rethink everything, the James Webb Telescope has just discovered even more stuff that's flipping our theories upside down. Telescope finds redefine universe theory. The telescope has found that the universe is expanding way faster than we expected. This accelerated expansion is linked to something called dark energy, a force that pushes everything apart, working against gravity. This new info really throws a wrench in our existing models, which means we might need to rethink the whole idea of gravity and cosmic forces. It's possible that we're on the brink of new theories that go beyond what Einstein told us with general relativity. And that's not all. The telescope has also spotted massive galaxies and black holes that formed way earlier than we thought possible, like just 1.5 billion years after the Big Bang. This challenges the traditional thinking around how black holes and galaxies form. It's kind of like discovering a city existed before the map said it could, which means we might have missed some crucial details about how things came together in the early universe. It's making scientists rethink the whole process of how these massive structures took shape. One theory that's gaining some attention because of these findings is the cyclic universe idea proposed by physicist Roger Penrose. He suggests that instead of the universe being a one-off event with a definite start and end, it actually goes through endless cycles, expanding, contracting, and then repeating. The surprising presence of huge cosmic structures in the early universe and the unexpected speed of the universe's expansion seem to line up with this theory. It's like the universe is part of a never-ending loop of creation and destruction, where one cycle leads to the next, almost like a cosmic reset. These discoveries also put some serious pressure on the standard model of cosmology, called the Lambda CDM model. This model relies on dark energy and cold dark matter to explain the universe's makeup. But the new findings, especially the existence of massive structures way earlier than we thought, are making that model look a little outdated. If the universe is expanding faster and forming giant structures earlier, we might need to rewrite some parts of our theory to make sense of it. On top of all that, there's another big concept making waves: quantum gravity, uniting the universe. Quantum gravity is all about merging the two big ideas in physics: quantum mechanics, which deals with the really tiny stuff, like particles, and general relativity, which is our best theory of gravity, mainly at big scales. The goal is to come up with a theory that works at both extremes and explains what happens when quantum effects and strong gravity collide. Think black holes, the start of the universe, and even some models suggesting the universe might go through cycles. When it comes to black holes, they're these super weird places in space where gravity is so strong that nothing, not even light, can escape. In Einstein's general relativity, black holes have what's called a singularity at their center, where everything gets crushed into a point with infinite density. But quantum mechanics, which rules the microscopic world, suggests that infinite density can't really exist. Quantum effects might stop that from happening. That's where quantum gravity theories like string theory and loop quantum gravity come in. They're trying to fix this by adding quantum mechanics to our understanding of space and time. For example, loop quantum gravity proposes that space itself has a discrete structure at tiny scales, kind of like pixels in a digital image. This could stop the formation of singularities by preventing the infinite crunch of matter. As for the early universe, quantum fluctuations might have played a big role in how galaxies formed. These tiny fluctuations could have influenced how matter spread out and clumped together, leading to the galaxies we see today. Quantum gravity could help explain how gravity and quantum effects worked together during those early stages. One fascinating thing we're starting to notice is that supermassive black holes seem to have popped up pretty quickly after the Big Bang, which raises questions about how they grew so fast. Figuring out the quantum gravitational processes behind this rapid growth is a huge focus of research right now. There are also ideas about the universe not just having one Big Bang, but instead going through cycles of expanding and contracting. These models, known as cyclic or oscillating universe theories, suggest that when one universe ends, another one begins, potentially avoiding the singularity at the start of the universe. Quantum gravity could offer a way to explain how the universe transitions from one cycle to the next without hitting a singularity. Loop quantum gravity, for instance, suggests that when the universe contracts, it could then transition into another expansion phase smoothly, without a big bang-type singularity. And while we're on the topic of discoveries, there's another possibility that's been gaining traction lately. Could there be a multiverse? The James Webb Space Telescope has seriously changed the game when it comes to understanding our universe. It's given us some pretty mind-blowing insights that have even started to challenge and expand on big theories, like the multiverse and the idea that the universe might go through cycles. One of the most exciting things the telescope has found is these supermassive and bright galaxies from the early universe. These discoveries have thrown a wrench into some of the standard ideas we've had about how the universe formed and evolved. For example, finding black holes in these early galaxies was a huge surprise. It turns out that these black holes might actually help explain why these galaxies are so much bigger and brighter than we expected. This finding has cleared up some mysteries that were starting to poke holes in the Big Bang theory, which is pretty important since it's been the main way we've explained the universe's origins. These discoveries make us think twice about some of the old cosmological models and open up the possibility of considering something like the multiverse theory. The multiverse idea suggests that there's not just one universe, but a whole bunch of them, each with its own unique set of physical laws and constants. So, if our universe is part of a multiverse, the strange properties we're seeing in early galaxies could be a result of different physical laws or conditions that exist in neighboring universes. In other words, our universe might not be the only game in town. Now, don't get me wrong, the telescope's findings haven't directly proven that the multiverse exists, but they do make us think more about the bigger picture. The weird stuff we're seeing in these early galaxies, especially the supermassive black holes, really makes us question our current understanding of how everything came to be. As we dive deeper into these cosmic questions, we're entering a whole new chapter in space exploration. New era in space exploration. One of the coolest things about the telescope is its ability to see in the infrared spectrum. Basically, it can see light that we can't with our eyes, which is awesome because it lets the telescope peek through cosmic dust clouds. That means it can see galaxies, stars, and even planetary systems that were previously hidden from our view. It's kind of like having a superpower to see into the past, right? By capturing infrared light, the telescope can give us a look at the early universe, something we've been dying to understand better. The technology doesn't stop there. The telescope is equipped with some seriously advanced detectors. These things are bigger, more sensitive, and way more durable than the ones used in previous telescopes. Because of this, it can pick up faint signals from objects that are so far away, it's almost like they're barely visible. These detectors help the telescope see things that were once out of reach, giving us a much clearer picture of deep space. And let's not forget about the sun shield. This thing is massive, about the size of a tennis court, and it's made of 5 layers of special materials that protect the telescope from the sun's heat. Why does that matter? Because the telescope needs to operate at super cold temperatures to work its infrared magic. Without this shield, it wouldn't be able to see the universe in the way it does. It's a seriously clever piece of design, and it's crucial for the telescope's success. But while the James Webb Space Telescope is making waves, it's not the only one out there. There are a few more space missions that are about to launch, and they're going to push our understanding of the universe even further. For example, there's the Euclid mission, run by the European Space Agency. This one's all about mapping the dark universe. Euclid will help us understand the nature of dark energy and dark matter by measuring how fast the universe is expanding. Basically, it'll give us some of the most important clues about these cosmic phenomena that have been puzzling scientists for years. As we uncover more about the universe, it's clear that we might need to rethink everything we thought we knew. Rewriting the rules of the universe. The James Webb Space Telescope on the early universe and what it's showing us is totally blowing our minds. One of the biggest surprises is that some of the galaxies it's observed are way larger and brighter than we ever thought they could be. Current models of how the universe works, especially the ones that rely on dark matter to explain how galaxies form and evolve, can't fully explain these findings. If these galaxies are so much bigger and brighter than predicted, it suggests that maybe there's something else going on that we don't fully understand yet. It's possible that gravity works differently than we thought, or maybe there's some kind of matter out there that we haven't even detected yet. Either way, it's clear that we need to rethink how we've been viewing the universe. Another mind-blowing possibility is that the telescope might have found something called dark stars. These are hypothetical stars that could be powered not by the usual nuclear fusion, but by dark matter annihilating itself inside the star. If this pans out, it would be a huge deal because it would give us actual, direct evidence that dark matter plays a role in star formation and evolution. It would be like solving one of the universe's biggest mysteries right before our eyes, and it could completely change the way we think about how stars are born and evolve over time. These discoveries are really throwing a wrench in the works of the standard cosmological model. For a long time, scientists have relied on dark matter to explain how galaxies form, but the fact that early galaxies seem so much brighter and bigger than we thought means that dark matter might not be the whole story. It could mean that dark matter behaves in ways we didn't expect, or there might be entirely new forces at play that we've never considered. Either way, scientists are going to have to get creative and explore some alternative theories to make sense of all this new data. The data from the telescope has also confirmed that the universe is actually expanding faster than we thought. Previous models predicted a certain rate of expansion, but the new numbers show that the universe is expanding about 8% faster than those models suggest. This discrepancy is part of what's called the Hubble tension, and it's raising all sorts of questions. It's possible that dark energy, or some other unknown force, is causing the expansion to speed up. This finding suggests that there's still a lot we don't understand about how the universe works, and we're definitely going to need more research to figure out what's actually driving this faster expansion. What do you think? Leave your thoughts in the comments below, and if you liked this video, don't forget to subscribe to our channel. See you in the next one.